Alright guys, Mr. E here on notes for 10-5, which is talking about area and perimeter of composite figures or shapes. We'll talk about what that means. Alright, so the essential question for 10-5 is going to be, I know on the Google Slides it says, how do I find the area of polygons? But for 10-5 is, can I find the perimeter and area of a composite figure? All right, so for this first video, we're going to just talk about perimeter first, and then on the second video, we'll talk about the area of a composite figure. All right, so perimeter of any polygon is the sum of the lengths of its sides. Sorry. So for example one, we got to find the length of all the sides of this parallelogram so we can find the perimeter. Alright, so if you want to find the lengths of the sides for this parallelogram, we can easily find the length of two of its sides. If you were to find the length for this top side and this bottom side, both of them should be 8. If you count the boxes, otherwise you can use the ordered pairs. Is a -1, 7 for this first ordered pair. This is 7, 7. So the distance between the x values should be 8 units. So the distance between -1 and 7 should be 8. Same thing down here. This ordered pair is what is that? 2, -3. And then this is 10, -3. Again, the distance between the x values should be 8. So we were able to find the length of those two sides of that parallelogram, but now we got to find these slant sides, or these diagonal sides, I guess. They're not straight, they're diagonal, they're, in other words, slant. So we have to use prior knowledge to figure out what those lengths are going to be. So we have to, in this case, a best practice probably would be looking to create a triangle, a right triangle more specifically, so that you can use a Pythagorean theorem. So here we have one triangle here, otherwise you could have done it on this other side if you wanted to. Same thing, you have a right triangle. It's the same right triangle, so it doesn't matter which one you use, to be honest. As long as you can identify a triangle, then you can use the Pythagorean theorem. If you recall, the Pythagorean theorem states a squared plus b squared equals c squared. So in this case, again, the longest distance is our c value. So it's always across the 90-degree symbol. So that's why that is our c. The other two lengths can be considered our a and our b. So this vertical distance, if you count out the units, should be 10. That can be either our a or our b. And this other distance down here is 3. So if you plug in the numbers into the Pythagorean theorem, you should have 3 squared plus 10 squared equals c squared. So if you use the Pythagorean theorem, you can find the distance for c. So this is 9 plus 100 equals c squared. That's 109 equals c squared. And again, if you recall, if you want to get c by itself, you have to square root both sides. So c ends up being roughly about 10.4 units. So that is our distance for c, 10.4 units, about. So we have both these diagonal distances, slant height. This is also 10.4 about. So if we want to answer the question, find the perimeter. All right, so the perimeter is equal to the sum of all the sides. So we have 8 and 8. 8 plus 8. And then we found out recently that it's the other slant height is 10.4 and also 10.4, since they're the same essentially because they're opposites. Opposite sides of a parallelogram are the same. So if you add those numbers together, that is 36.8 units. Now, because perimeter is distance around the circle, we're not squaring the units, it's just units. All right. So that is the distance around. So roughly, because we rounded the slant height using the Pythagorean theorem. So for the perimeter for this first shape, this parallelogram is 36.8 units. All right, so going on to example 2, which is finding the perimeter of this triangle below. So again, we might have to use the Pythagorean theorem, we might not, but it looks like we will have to. Again, for the perimeter, we got to find the length of all the sides. So let's start with finding the length of the easiest side that we have here, which is this bottom length, which is 6 units. You can count the boxes, otherwise you can use the ordered pairs. This is -5, -5. This is 1, -5. And then up here it's -3, 3. So we found one of the sides, but we gotta find the others. Again, gotta use Pythagorean theorem, create a right triangle here, so that we can find this length. I'm gonna call green the C length right there. So again, we have to go back and take a look at these distances. This is 2 units for the right triangle, and this should be a total of 8 units for this side of this right triangle there. So again, using the Pythagorean theorem, a squared b squared equals c squared, we should end up for this first computation should be 2 squared plus 2 squared is 4, 2 squared plus 8 squared, which is 64, should equal our C length, or C squared length. So then, again, it just involves a little simplification. 64 so 64 plus 2, sorry, 64 plus 4 is 68. Again, if you want to get C by itself, we have to square root it, square root both sides. So then our C value is about 8.2 if you type it into your calculator. Again, if you recall, use your calculator that you have on your iPad, you would have to do second and then x squared to get the square root, which is, then you type in the number, which is, again, it's 8.2 roughly. All right, so that's for that first green length that we found there. So again, we want to find the other side, so we're going to use a similar process. So I'm going to call this, I don't know, call this S. I don't want to use C again, so I'm going to call it S. Again, we're still trying to look for a right triangle here so that we can use the Pythagorean theorem. It looks like this length is also 8. This length up here is 4 units if you count them out. So then it should be 4 squared plus 8 squared. So 4 squared plus 8 squared equals, we used s squared. So again, simplifying, we have 16 plus 64 equals s squared. And if you add those two numbers together, that is 80. And again, square root both sides. S is about 8.9. So we figure out all the sides. So the perimeter for this triangle here is equal to the 6 that we found easily at the beginning. That's 6 plus 8.9 plus 8.2. So the perimeter of this triangle is about 23.1 units.